This is January 06 question 2. Define the term moment as used in mechanics. The term couple as used in mechanics. So a couple, that's a bad pen again. A couple consists of two forces which are equal. In size, I'm going to write size instead of magnitude to save a little bit of space. In size, opposite in direction, whose lines of action do not coincide. Now, I would learn those 3 points when you're defining a moment or a couple. That the forces are equal, that they're opposite, and their lines of action do not coincide. And I would put in there too, overall producing a turning effect. Right, a double-handed wrench is used to open a water valve. The torque required to turn the valve stem, so you're going to take it and turn it round like that, or like this, as it is in this diagram. The torque required to turn the valve stem is 22.4 Newton meters. This is achieved by applying equal and opposite forces of 64 newtons perpendicular to the ends of the wrench handles as shown in the diagram. You see your 64 newtons. Show that the distance L between the points of application of the forces is 0.35 meters. So we know that the moment of a couple is equal to the force, one of the forces multiplied by the distance between them. So that's 64 times L. And you're told that the moment required, or the torque required, is 22.4 Newton meters. And therefore, whenever you divide 22.4 by 64, the length comes out to be 0.35 meters, as expected. But you should, of course, write your equation out and the numbers underneath if you're going to show. It's very, very important you do that really clearly. To open the valve requires a rotation of the valve stem by 40 degrees. And 40 degrees is 0.111 of a complete revolution. As the wrench is rotated, the point of application of each force moves along the arc of a circle. The forces remain constant in value and perpendicular to the arms of the wrench. Show that the distance the point of application of one of the forces moves along the arc of the circle is 0.122 meters. Now, what you're showing there is that wee distance there, and you're trying to show that that wee distance is 0.122 meters. So you know that's part of the circumference of the circle, if I draw a wee line out there. But you also know that the amount of the ratio of the rotation of that is 0.111 of the entire circumference of the circle. So really what we're trying to work out is the, sorry, I'm realising you can't see that. So this is the 0.122 meters that you're trying to prove. This is the ratio of the entire circle that it's moved by, and this is 0.111 of a complete rotation. And so you're going to work out the circumference of the circle and multiply it by 0.111 to hopefully to get 0.122. So circumference of a circle, C is equal to pi times D. But we want 0.11 of that. So our length here, our distance, is equal to 0.111 multiplied by pi. And the diameter of the circle is the length between the two forces, and that's 0.35 meters. And when you multiply all that out, you get 0.122 meters, as expected. But you must be very clear about that too, because again, they're giving you the answer and they're asking you to show. Hence, calculate the work done in opening the valve. So the work done is equal to the force multiplied by the distance. The force used is at each end 64 times 0.122. The distance, and that gives you 7.81. But that's only the work done by one hand. And therefore the work done by two hands is equal to 7.81 multiplied by 2. And that comes out as 15.6 joules. So works force by distance, one hand, 64 by 0.122 is 7.81. Then with both hands, the total amount of work done is 7.81 by 2, which gives you 15.6.